Welcome! Today we're going to derive the derivative of the square root function using the limit definition of the derivative. Let's start with our function f of x equals the square root of x. Let's recall the limit definition of the derivative. The derivative f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Now, let's substitute our function into this definition. We get the limit as h approaches 0 of the square root of x plus h minus the square root of x, all divided by h. This is where it gets tricky. We need to rationalize the numerator to eliminate the square root in the denominator. We'll multiply both numerator and denominator by the conjugate of the numerator, square root of x plus h plus square root of x. Let's simplify the numerator. In the numerator, we multiply square root of x plus h minus square root of x times square root of x plus h plus square root of x. This gives us x plus h minus x, which simplifies to just h. Now we can cancel the h in the numerator and denominator. This gives us 1 over square root of x plus h plus square root of x. Now we can evaluate the limit as h approaches 0. As h approaches 0, square root of x plus h approaches square root of x. So we get 1 over 2 times square root of x. Let's visualize what this means graphically. Here's the graph of f of x equals square root of x, and at any point, the derivative gives us the slope of the tangent line. For example, at this point where x equals 1, the derivative equals 1 over 2 times the square root of 1, which equals 1/2. This means the slope of the tangent line at x equals 1 is 1/2. In conclusion, we've shown that the derivative of the square root function is 1 over 2 times the square root of x, using the limit definition of the derivative. This required some clever algebraic manipulation, particularly the rationalization of the numerator, but following the steps carefully led us to our final answer.